Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 8.6 guided notes on surface area of prisms. Now, we've already talked about volume of prisms, and that's the amount of space inside of a shape. Surface area is an area of two-dimensional shapes, but on three-dimensional figures. So it measures the total area of all of the faces of a three-dimensional figure. Now, while we could take a three-dimensional shape and lay it flat, which you may have done back in elementary school, where the teachers gave you a two-dimensional shape that looked like this, that you had to cut apart and then put together to form a rectangular prism, or they probably called it a box back then. That's called the net of the three-dimensional figure. And if I find the area of all these rectangles that make this figure up, I can find the surface area of this figure. For example, we have two sides that have dimensions length and width, so LW, which is where the 2LW comes from in the formula. We have two sides of dimensions length and height, which are these two sides right here. So 2LH, that's where this comes from in the formula. And we have two sides with dimensions width and height, which is this side and this side here. So we have two sides with area 2 times, well, each of them is W times H, and there are two of those, and that's where this comes from here. So the formula comes from somewhere. It's not just a formula that's randomly made up, but it's much easier to just have a formula where we can plug and chug instead of having to break this figure down into 6 different faces and find the area of each and add them together. So the formula for the surface area of a rectangular prism is 2LW plus 2LH plus 2WH. On your formula sheet, you'll see SA equals. I've also seen S equals for surface area. If you want to find the surface area of a cube, and I believe this is on the formula sheet, although you're going to need to copy this into your guided notes. Let me go ahead and highlight it in yellow. The surface area of a cube is 6s squared. Every side has area s to the second power, and there are 6 of them. So the surface area is 6 times s squared. Let's go ahead and do a few examples. And I do want to mention that for the cube, you can use this formula up here, the 2LW plus 2LH plus 2WH. It's just a whole lot more work, although the length, width, and height will all be the same. So you'll get 3 products that are equivalent. Let's go ahead and take a look at a few practice problems. It asks us to find the surface area of each of these solids, showing our work, of course. That way we can see if you made a mistake someplace, where that mistake is, round to the nearest tenth if needed. We will not need to do that for these first 2 examples. Number 1, the surface area. I know on your notes it says SA. I have S here. That's just because it's an older version, but again, S and SA both represent surface area, equals 2LW plus 2LH plus 2WH, since this is a rectangular prism. The first thing I would decide is which side is going to be your length, which side is going to be your width, and which side is going to be your height. I chose 5.8 for the length, 2.1 for the width, and 2.8 for the height. But you can choose them differently. You'll get the same products. They might just be in a different order. All right, so let's plug these in. So start with 2LW, which is 2 times 5.8 times 2.1. I definitely decided to use parentheses for multiplication here, so I didn't confuse my decimal point with multiplication. 2LH is 2 times 5.8 times 2.8, and 2WH is 2 times 2.1 times 2.8. Let's go ahead and calculate those products. Our first product is 24.36. Our middle product is 32.48, and our last product is 11.76. We'll go ahead and add these together, and we get a surface area of 68.6. Note the label that we put on this, it's feet squared, since it is an area. Yes, it's a 3-dimensional shape, but we are finding the area of all of the flat surfaces, which are 2-dimensional. So 68.6 feet squared. Let's go ahead and take a look at question number 2. First, I chose my length, width, and height. So 22, 13, and 14. My formula is 2LW plus 2LH plus 2WH. So that will be 2 times 22 times 13, plus 2 times 22 times 14 for 2LH, and 2 times 13 times 14 for 2WH. Now, I do recommend doing this next step where you calculate each of these products. If you try to plug it all in one step, it's really easy to accidentally replace a multiplication sign with a plus sign or a plus sign with a multiplication sign. So our first product, 2 times 22 times 13 is 572. Our middle product, 2 times 22 times 14 is 616. And our final product, 2 times 13 times 14 is 364. And that's going to get us a surface area of 1,552 inches squared. Okay, so we're going to shift gears to surface area of a triangular prism. You should have been exposed to this formula in 6th grade. We used to do a different formula in both 7th and 8th grade for surface area of triangular prisms, but they've made it consistent between 6th, 7th, and 8th grade, the formula that's used. So the formula for the surface area of a triangular prism is BH plus AW plus BW plus CW. So base and height are going to be the base and height of your triangular base. So you want to start by identifying the triangular bases, so identifying the front and back, top and bottom, whatever your two triangular bases are, and identify the base and height because they intersect at a 90-degree angle, which we've talked about many, many times. The width of our prism is going to be the distance between the two triangular bases, like we saw with our volume formula. So this part so far really sounds a lot like our volume formula, but we're talking about surface area, so we have a little bit more to our formula. So that AW plus BW plus CW, we've already talked about the width of the prism. We've already identified B. Now A and C, those are the ones that I noticed my pre-algebra students struggling a bit with, but A and C are the sides of the triangular bases that are not the base B. So we'll talk about that, but what I will do is I'll actually pull the triangular base off and redraw it and identify all of the sides of that triangular base, because we want to make sure that between A, B, and C, we're using all three sides of our triangular base. So this is not an easy formula. I think identifying base, height, and W are pretty easy, but A and C can be a little bit tricky. So let's try a problem. We're actually going to get into number 3. So for number 3, we can identify the base and height by identifying our 90-degree angle. Now I'm actually going to highlight my triangular base in yellow. I'm going to identify both of them since there are two triangular bases. So there's the top, there's the bottom. Go ahead and highlight that. There we go. So these are my two triangular bases, and what you'll notice is down here I actually sketched the triangular base that I highlighted here. And I identified the three sides of that triangular base all as 4, since we've got our 4 on our bottom here. And then if we go to our triangular base at the top, we've got those other two 4s. Now we notice a 90-degree angle here. So my base and height meet at a 90-degree angle. So I chose my base to be 4. Go ahead and reveal that. There we go. I chose my height to be 3.5 because they meet at that 90-degree angle. And then the width of the prism is going to be the distance between your two triangular bases. So this 4 right here is going to be the width. Now, I've used 4 already. So I used this 4. Let me go and highlight this in purple. I've used this 4 down here for the base. So A and C both have to be 4 as well, since those are the other two sides of my triangular base. So you're going to notice that I identified A and C each also as 4. Once you have that identified, it's really just a matter of plugging the numbers into the formula. So we're going to do BH plus AW plus BW plus CW. So that would be 4 times 3.5 plus 4 times 4 plus 4 times 4 plus 4 times 4. So I did do each of those products to get 14 plus 16 plus 16 plus 16. And then our final surface area here is going to be 62 meters squared once we plug those in. Keep in mind for surface area, since it is a type of area, we are going to use a label of meters squared, inches squared, feet squared, whatever that may be. All right, so number 4, I'm going to go ahead and highlight my two triangular bases in yellow again. So we have another triangular prism. And you're going to notice that I redrew it over here, which my 10 is kind of hidden. We'll reveal that here in a moment. But the three side lengths of my triangular base are 10, 11, and 14.9. The 14.9 comes from this triangle back in the back. Since our triangular base happens to be a right triangle, these can be the trickiest ones for students. I'm going to identify my base and height as those that intersect at a 90-degree angle, which I can see here. So I chose to let 11 be my base and 10 be the height. Now those are interchangeable, but we want to stick with whatever we chose for B as we go to identify A, B, and C for our triangular base. So I let my base be 11, my height be 10, and then the width of our prism here is going to be 20. Again, that's going to be the distance between those two triangular bases. Now, identifying A, B, and C, I'm going to use purple or pink here. I've already used B to be 11, so A and C have to be the other two sides I haven't used. So I'm going to let A be 10 and C be 14.9. Now, keep in mind that A and C are also interchangeable, so they can be in a different order. But since I chose B to be 11, I need to use the 10 and 14.9 for my other two sides. So now we just plug them into the formula. So as we do that, we're going to have base times the height, which is going to be 11 times 10, plus AW, which is going to be 10 times 20, plus BW, which is 11 times 20, plus CW, which is 14.9 times 20. Again, I did find each of those products before calculating the final answer. It's a lot to plug into your calculator in one step. So each of those products was 110, 200, 220, and 298. When you add those together, you get a final surface area of 828 feet squared. All right, let's look at one more of these before we go on to some other types of prisms. So number 5 is another triangular prism. I'm going to highlight my triangular bases, and you can see that I sketched it down below as well, which we'll show here in a moment. So these are my two triangular bases. I also notice a right angle. So I've got that right angle right here, which is where my base and height are going to meet. As I slide down a little bit here, you're going to see that I copied this triangle down. One of the sides is 12, the other two are 10 as identified back here in the back. So I need to use 12, 10, and 10 as my A, B, and C. Now because my base and height intersect at a 90-degree angle, I chose my base to be 12 and my height to be 8. And then the width of this prism is going to be, move this box out of the way if I can. There, get that out of the way. There we go. I chose my width to be 15 here because that's the distance between the two triangular bases. And again, 12 and 8 intersect at that 90-degree angle, which is why my base is 12, my height is 8. Now, at this point, I've already used the 12 as my base. Not a very straight line there. So I've used 12 as my base. So A and C have to be the other two sides. So A and C are each going to be 10. Again, for A, B, and C, we have to use all three sides of your triangular base. So it's not a bad idea to redraw the triangle and maybe check them off as you go, highlight them as you go, or make sure that you've used all of those sides of your triangular base. All right, let's plug that in. So surface area is BH plus AW plus BW plus CW. So that's going to be 12 times 8 for my base times my height, plus AW, which is 10 times 15, plus BW, which is 12 times 15, plus CW, which is 10 times 15. Once I calculate all of those products and then add them together, I should get a surface area of 576 meters squared. Now we've talked about rectangular prisms, we've talked about triangular prisms. Let's talk a little bit about what happens when we have other types of prisms. So a polygonal prism, we're going to use this for anything that isn't a rectangular or triangular prism. The formula is pH, which is perimeter of the base, times the height. We also call the height the width of the prism, plus 2 times capital B. Capital B represents the area of the base. We saw that in our volume formula. Again, H is the distance between your two parallel bases. We also sometimes call this W. So for the examples we're going to see, we're going to be giving you the perimeter of the base and the area of the base. Not that you couldn't figure those out depending on what shape our base is, but we don't know how to find the area of a pentagon or an octagon or
anything like that at this point. So let's go back here to question number 6. And we're going to use, since it's a polygonal prism, specifically an octagonal prism here, we're going to use pH plus 2 times capital B. The perimeter of the base is given at 32 meters. The height is the distance between your two parallel bases, that is 2.8 meters. And then the area of the base is 45. So we're going to do 32 times 2.8 plus 2 times 45. I did just plug that into my calculator in one single step, and that got me 179.6 meters squared. All right, our last example with just finding surface area of simple shapes, we do have a pentagonal prism, and we are given the perimeter of the base, the area of the base, and the width, the distance between those two pentagons, which is 6. So we'll plug perimeter of the base in as 25 times the height or width of the prism, which is 6, plus 2 times area of the base is 2 times 125. And our total surface area will be 400 centimeters squared. Again, I just plugged those into my calculator in one single step there.
All right, let's take a look at our 2 word problems. Number 10. Oh, sorry, this is number 8 in your guided notes. I don't know why it shows number 10 there. This is number 8. Go ahead and put an 8 above this. This must be something old from the guided notes that perhaps I changed at some point. So let me cross off the 10. This is number 8. Mara is going to wrap a box in the shape of a rectangular prism with dimensions 15 inches, 18 inches, and 3 inches. First thing we want to do is find the surface area of the box. Since we're going to wrap it, that's going to go on the outside of the box. So this is 2LW plus 2LH plus 2WH. It does not matter which one is length, width, or height. So I chose my length to be 15, my width to be 18, and my height to be 3. So we have 2 times 15 times 18 plus 2 times 15 times 3 plus 2 times 18 times 3. Our 3 products will be 540, 90, and 108, and they can be in any order. And my surface area will be 738 inches squared. So quite a bit of surface to cover with this wrapping paper. Now part B, the wrapping paper costs 5 cents per square inch. I think I finally changed this to be something much smaller in my pre-algebra guided notes, but it wasn't significant. I guess it was 2 cents per square inch, but since the wrapping paper costs 5 cents per square inch, what will be the cost to wrap the box? Well, if we know the number of square inches we have to cover, we'll multiply that by 5 cents, which is 0.05, and that's $36.90. Thank goodness wrapping paper is significantly cheaper, unless you're using the really fancy wrapping paper, but we get $36.90. I think I used to have like 25 cents per square inch, and I was like, whoa, that definitely doesn't make sense. So I made it a little bit smaller, so it's closer to reasonable, but still probably a bit too high. All right, let's go ahead and take a look at our last question, number 9. It's going to be called number 11 again. It must be from an old version of the guided notes, so I'll cross that out here, no big deal. So number 9, it says Pam is designing and painting a ramp for her elderly grandmother to use to get into her house. It is shaped as shown below. Part A is to find the surface area of the ramp. So we're finding the surface area of the entire ramp. That being said, you might not paint the bottom of this since it's not going to be seen, but we're going to assume we're just going to paint it here. It is a triangular prism. So first things first, let's find the perimeter of the base, and I'm going to highlight the base in green. Now, I don't believe you have any word problems related to surface area of triangular prisms on your test, but I still think it's good for us to take a look at. You do have a similar one to the wrapping paper question, though. So for perimeter of the base, we are going to add 6 to 6.5 to 2.5. 6.5 is the diagonal side, the ramp part. That's going to get us a perimeter of 15. Now the base and the height, I know there's no right angle here, but assuming we want this to be a safe ramp, we would have a right angle right here, so this would be the ramp. 2.5 and 6 will be the base and height of your triangular prism. So we're going to do, whoops, don't want to go there. We're going to do half times 2.5 times 6, which is going to get us 7.5 for the area of the base. To find the surface area, we do the perimeter of the base, which is 15, times the width, which is 4.5. Highlight that in blue right here. There we go. Plus 2 times the area of the base is 2 times 7.5. That's going to get us 67.5 plus 15 for a surface area of, let me slide that up, 82.5 feet squared. Now again, if you're painting this, you're probably you're not gonna paint the bottom since it's not gonna be seen, but you also might paint more than one layer as well. So we'll take that into consideration in the next part. So in part B, it says 1 quart of paint covers 100 square feet. How many quarts of paint will be needed to paint the ramp? Since it's 82.5 square feet, 1 quart is going to be enough. Again, we might have to put 2 coats on or 2 layers of paint, depending on how much that wood or whatever materials you use, probably wood, how much it sucked up that paint. But considering we're probably not going to paint the bottom, 1 quart of paint should be enough. All right, so again, what we've talked about in this lesson, surface area of rectangular prisms, where we just plug and chug. Surface area of triangular prisms, keep in mind to use the formula for the surface area and volume, in the volume case, of a polygonal prism. And we also did a handful of word problems related to surface area. You won't have a lot of that on your test, but it's still something good for us to refer to. If you're looking for an example like the questions on your test that you'll see, of course, looking at problems 1, 2, 3, 4, 5, definitely a good idea to look at. But also number 8, Mara and wrapping of the rectangular prism, wrapping that box, definitely good questions to take a look at. Thanks for listening.